Okay, hello everyone. Um, we're going to do parts of a whole, the lesson that we did the other day. So, students, you need to be able to break up the molecules or whatever formula you've got, something that has a number of parts in it, and break it up and find the mole and the mass and the number of the parts. So, if we look at carbon dioxide, it's possible to state for the carbon dioxide the mass of the whole carbon dioxide, the number of mole of the whole carbon dioxide, and the number of actual carbon dioxide molecules. You need to start getting used to little m being mass, little n being the number of groups, moles, and n being the number of actual particles, so molecules or atoms or ions. So once we've got a whole thing with a number of parts that we can break up, we can find the mass or the number of moles, the number of groups, or the number of actual atoms or parts. Alright, so the first thing that you need to do is when you're going from a whole thing to the parts is relate the number of moles. So once you have the number of moles, the number of groups of your whole thing, then you can work out the number of groups of whatever parts you're trying to relate. Later on we'll look at this where it doesn't have to be a whole and a part. We'll be able to relate to moles of anything really, so you could relate parts to other parts. This relationship that we're looking at, this ratio, we can use for lots and lots of things. So you need to start getting used to me writing it like this. So whatever we're trying to find, I'll always put on the top. That'll be your x, whatever you're given. So what we want is on the top, what you've got is on the bottom. And you need to know how those two things go together. What's the relationship between them? So I'll do an example with cars. One car has 4 wheels. Yeah, so why I picked cars. So whenever you're trying to work out groups, you need to try and make sense of a simple example. So one molecule, one of something. How, when you break it up, how many of whatever you're looking at, the parts, how many are there? So you need to get this simple relationship going. So a 1 to 4 relationship. Once you know that it's always 4 times the number of wheels for cars, once you know it's a 1 to 4 relationship, then it doesn't really matter how many you have. This will always be 4 times that amount. So if you have 10 cars, you'll have 40 wheels. If you have 100 cars, you'll have 400 wheels. If you had 13 cars, you'd have 4 lots of 13 for wheels. So it's a different relationship for headlights. For every 1 car, there's 2 headlights. So this is always double of that. So if you have 10 cars, you've got 20. If you've got 100, you've got 200. Different relationship for seats. So it's a 1 to 5. So you can see the pattern. So that's what you need to get the simple pattern going, and then you'll be able to do it for however many you've got. So no matter how many cars you've got, or later on we'll look at groups, no matter how many groups you've got, whatever amount you have of the whole thing, you'll always multiply that by 4 to get for wheels, and multiply it by 2 for headlights, and multiply it by 5 for number of seats. So all of these examples so far have looked at number. They're all counting numbers. Like you use an N for counting numbers. So in our whenever I talk about number, I'll use a capital N. So 12 is a great number to pick. 1 car, 12 cars. So the parts, 4 lots of that. It's 4 wheels. 4 lots of this would be 48 wheels. So the same relationship between headlights and a 1 to 2. So this is twice the amount. So you just multiply. You've got 12 cars. Each car has 2 headlights, so it's 12 lots of 2. In this case, it's 12 lots of 5. 12 times 5. I think probably everyone's okay with that. Mathematically, there's different ways of writing this. It's a 1 to 4 relationship. Or I can write it like this as a fraction. It's a 4 to 1 relationship. 4 times the number on the bottom. Or, so this is saying that if I have 4 wheels, then I would have 1 car worth of wheels. This is saying if I have 1 car, then I have 4 wheels. So it's a different way of looking at the relationship. So we need to scale these up because we're going to work in large numbers. So we can't always count individual things. So in Year 11 we'll be interested in the number to start with, but then eventually in Year 12 we don't look at the number anymore. We only work in groups of things because they're so small atoms that we have to work only in groups. So I picked 12 because you're already familiar with the group name word, a dozen. So if I say a dozen, 1 dozen, you automatically know that I'm talking about a lot of things. You know that this word doesn't mean I've got one thing, it means I have a lot of things. So this word dozen, you're probably quite comfortable. If I say a dozen, automatically in your head you'll think 12. So if we still do it groups, if I have a dozen cars, then I will have 4 dozen wheels. Each car broken up will make 4 wheels. So if I put them into boxes, if I broke a car up and put 1 wheel in this box, 1 wheel in that box, 1 wheel in this box, 1 wheel in that box, and then I did it again and again, 12 times, the boxes would gradually get filled up until each box had 12 wheels in it, and I had 4 boxes. So I have 4 dozen wheels. Different for headlights, there's only 2, so if I broke a dozen cars up and started to fill up boxes, every time I broke a car up, if I broke a dozen cars up, I would have 2 boxes with a dozen wheels in each, or 5 boxes with a dozen seats in each. So the relationship's the same. Don't let these group words confuse you. If you know 1 car has 4 wheels, then 1 dozen cars will have 4 dozen wheels. Sometimes the more you think about it, the more confused you get. Just keep it simple. So instead of a group word a dozen, we'll use a group word of mole. So this group always has 12 in it. This group always has 6.02 by 10 to the 23 in it. So if I broke each of these cars up and put them in a box and kept doing it and doing it for every single car, I would eventually have 4 boxes with 6.02 by 10 to the 23 wheels in each box. So I have 4 moles. A mole is a group. You can think of it as boxes. That might be the easiest way. So once you know what one thing is, then you can just substitute a group word in and use the group word for the same pattern. Okay, so there's 20 cars, how many wheels? So this is a counting question, isn't it? I'm not talking about groups at the moment. I've gone back to my N, my counting. So if we mathematically do what you were doing in your head, you put what you want on the top. So the question, how many wheels? That's the question. The number, N, of wheels. And what you've got is 20. So this is what you've got. And we know the relationship between cars and wheels is a 4-to-1 relationship. What number are we going to put on the top? Okay, so what we want, number of wheels, the number that we put on the top is 4. That's a 4-to-1 relationship. So these two must go together. The 4 goes with the wheels, the 1 goes with the cars. Once you get used to setting these up, then it's just really easy. So you've now got a mathematical relationship. If we take this number is divided on this side. We want it over the other side so we can work out the number of wheels. If you divide a number on one side, when you take it over the other side, you multiply it. You might do mathematically where you want to get rid of this on one side, so you multiply both sides by the number of cars, and that would cancel that out. Let's just get past that cancelling out step. You're going to end up with this being multiplied on that side, so let's just do it straight away. Okay, so we've moved it from here to here. It's divided, now it's multiplied. So the number of wheels is 4 times the number of cars, which makes sense, doesn't it? So this is just a mathematical way of writing out what we know already. If we've got 20 cars, each car has 4 wheels, it's 4 lots of 20, so it's 80. I want you to set these out the correct way though, so that it just becomes a habit. If you set it out the correct way, you don't make mistakes. You don't accidentally put the 1 on the top and the 4 on the bottom, which Year 12s still do. So if you do it correctly every time, there's no way you can put the numbers around the wrong way. The thing is, in Year 11, you need to start making this a habit. It's like writing the word number. You don't think about N-U-M-B-E-R anymore. You just do it because it's a habit. This needs to become a habit. Alright, so we've looked at counting numbers. Now we need to turn it into groups. So if you have a number of mole, so a group of a molecule, something with parts, you can also work out the number of mole, how many groups you would have of its parts. So if you have a whole group of something with parts and you break them up, you can work out how many groups you would have of the parts. So let's just make it make sense for a simple this situation where you've got one molecule, just one, and you break that up into its parts. So one molecule of carbon dioxide has 1 carbon atom and 2 oxygen atoms. So this is our relationship now. It's a 1-to-1 for carbon and carbon dioxide, and it's a 1-to-2 for carbon dioxide and oxygen. So if we turn this word molecule into a group word, it's just the same relationship. So one group of carbon dioxide will have one group of carbon atoms, 1 mole. One group of carbon dioxide molecules will have 2 groups of oxygen atoms, so 2 moles. If I draw this, so I changed my drawing so that we've got a dozen, because people are comfortable with the group word a dozen. So if we have a dozen, one group of carbon dioxide molecules, and we break that up, we will get 1 dozen of carbon. So each of these will make a carbon, and we'll get 2 dozen oxygen. So 2 groups of oxygen. Okay. So whenever we go from one group to the parts, like from a carbon dioxide to carbon, we need to know what the relationship is between these two things. So for carbon dioxide and carbon, it's a 1-to-1. For carbon dioxide and oxygen, it's a 1-to-2. So you need to know what is the relationship between them. Okay, so if we were doing oxygen, the number of parts of oxygen, and we had carbon dioxide, this would be a 2-to-1 relationship. So however many of the whole thing I had, I would have to multiply it by 2. Alright, so when you have a question, if we've got the whole thing, rather than working with whole numbers like 1s and 2s, that's easy to understand, let's do fractions of a group. So you don't have an entire group of carbon dioxide, you've only got a quarter of a group. Every time you see this word, you must remember that you're talking about lots and lots and lots and lots of carbon dioxide molecules in this group. So in a quarter of a group, you still have lots and lots and lots. Okay? So in the back of your mind, always keep remembering that this is a group word and it means lots of these. When you write out your questions, make sure you start labeling the information that you're given, because if you put a little label above it, it kind of starts leading you in the direction of what equation do I need. So we've got the number of moles of carbon dioxide, and the question is asking for the number of moles of carbon atoms. So you can see it's asking for the number of moles of carbon atoms. We're going from the number of moles of one thing to a number of moles of the other. So you can see we need a ratio. If you want to get even more fancy, start collecting it as a little, when you have a sentence, I've got the number of moles of carbon dioxide and it's 0.25. And I'm being asked to find the number of moles of carbon. That's my question. So that even makes it more obvious that you're going from a whole thing to the parts. So you need a ratio between them. So when you set up your ratio, you must set it up with what you're trying to find on the top. Before we get to that point, if you write out the whole thing, break it up into its parts, eventually we're going to do reactions where we have this like one reactant reacting with another reactant. So we'll be looking at the relationship between reactants. So it's good to get to become familiar with the numbers at the front of formulas, meaning how many of this entire thing. So we've got one of this entire thing and one of carbon. So one carbon dioxide molecule makes one carbon and two oxygens. At the moment it's really simple. So we want to know the number of moles of carbon. So we put that on the top. What we want on the top, well, the information that we've got, some information on the bottom, and the relationship between them. It's a one-to-one relationship. It's divided on this side, so you take it over the other side and multiply it. So that's your equation. So 1 times that, the same number. Eventually you'll just stop this and say it's the number of moles of carbon equals the number of moles of carbon dioxide. They are the same number. But we'll do it all properly to start with. So you just put in however many your example's given. So it's the same number. We do it for oxygen. It's a 2 to 1. Always make sure the number that's in front of here, the oxygen, is here. So these two numbers go together and this goes together. This is our relationship. Okay? So you always make sure that whatever you're relating here, they go together. Those numbers go together and these numbers go together. So that will stop you from putting a 1 on 2. Divide it on the other side, take it over the other side and multiply it, then put your example in. So equal signs, one on top of the other, and your answers have to have a unit. Miss Yeremenko gets people to underline or put a box around their answer, and I think that'd be a great idea if we did that too. Okay, so we've got our question, and I should have had this question up first and then done that, but anyway. So instead of something that's easy, a quarter of a mole, we're going to have 0.0342 of a mole. So you've got 3 numbers here, your answer should come out to 3 numbers. How many mole of oxygen? So we can see one of these has 4 oxygen. So our numbers are 1 to 4. So if you break it up and write it out, you can see it's a 1 to 4. Eventually you'll see that you could relate parts to each other if you knew how many oxygen you had in this. you could work out how many barium you would have altogether, how many mole. But we'll do that later. Alright, what you want on the top, what you've got on the bottom, the relationship is 4 to 1. Take it over the other side and multiply it, put the number in that you've got, and you've got your answer. Yeah? Alright, I'll do this in a separate video.